Rob G, 9th April 2023. Got my latest T28B project jacked up here. Just put the wing on it. Got to put a receiver in it before I can lower the landing gear. Alright, making some more form blocks for the parts for the T28R. So, last video I showed you making this piece here using this form block. So I thought I'd get more scientific for you. So I talked about putting a radius on the form blocks because this 2024 T3 metal is a hard heat-treated aluminum alloy, and you have to have a radius when you bend it. Otherwise, if you bend it too tight, it will crack on the back side here because the back side has to stretch a lot to make the curve. The inside gets shrunk. So I just eyeballed it, ran a file across it. Let's see how good I did now that I've dug out my radius gauges. So here's a 3/32 gauge. If we look at the original rib, that fits nice and tight. So it's a 3/32 radius on the part. We measure the radius on the inside of the parts when we do sheet metal layout. So we got a 3/32 radius. If I get my trusty form block here, see how good I did on it. Try to get everything where you can see it. So right there, I have a perfect 3/32 radius. Fits perfect on the block. Crash. So the part, we can check the radius here. It fits tight into the radius. Now this is slightly, I don't have these flanges bent exactly to 90 yet, but bending the metal over this form block, you're going to get just a slight bigger radius because the metal's hard. If you made it out of O-Soft, which is a annealed material, it would fit down tighter. So if I go to the next biggest, which is an 1/8 inch radius, that's about what I have on the part, but good enough for government work. Anyhow, if I use the 1/8 inch gauge on the original part, you can see just a little daylight where that radius is just a chigger tighter than the 1/8. The 3/32 fits perfect in there. And if you wanted to check the back, the 1/8 inch radius fits the back of the original part. This one I don't have the flanges quite 90, so I could bend these a little bit more, and it would be a anyhow, it a little bit bigger radius, which made this actually fit inside the original rib that's on the airplane. You'd have to have a slightly bigger radius to fit, to nest these two parts together like this, and that's what I'm doing, is putting this inside the former that's on the airplane, so it fit perfect the way it was made. Anyhow, I just wanted to show you how you would check the radius on these parts with these little radius gauges. I got a whole set of them here from I don't want to mention the place, it's in lots of towns. Anyhow, there's your radius gauge. You can check the inside, outside, inside. You could check the radius of a rod or something, and there you can see the, if you're going to check an outside radius on a part, you could use that, or you can use that, or you can and then you use this to check the inside. If you don't have a true 90, you can still check the radius using that point. So for the next part I'm going to make, I've got two form blocks here, and on this particular former, the bottom flange is bent one way and the top flange was bent the other direction, instead of, this one has both flanges bent the same direction. This particular former had one, the top one is bent forward and the bottom one is bent toward the back of the plane, and that's different. That particular former is different than on any other T-28 I've got around here. I've got 3 other fuselages to look at. So this was an A model that I'm working on. Originally was a T-28A, so they have a few different parts in them, and this particular piece came off of a B model. A lot of the parts interchange, some don't, so you have to research that when you're restoring these things. All right, so here I'm going to do a inside curve flange on this former. So when you're doing this, this is fairly straight, and this will lay down real quick, but up here on the inside of the curve, you got to stretch this quite a bit so this will lay down without ripping the metal, because if you just try to knock this down real quick, it's just going to tear the metal. So you have to stretch it and then fold it over. I'll try to hold the camera and do this. So you don't really want to hit in the sharpest part of the bend very much. You want to stretch this metal from here and here to give you the most metal you can have to stretch in the tight part of the bend. So instead of just trying to bend this down, it would just rip the metal, just tear it. So you have to massage that over gently as you go. Once you start getting it to rolling, we might use a little harder plastic hammer here to help to stretch this in here now. And get this down tight against the form block. I haven't really used one of these much. Might give it a shot. I kind of like that. You can see that metal just raise up and go back and forth as you hit it. A lot of tension in it. And this MDF won't take a whole lot of abuse. It's starting to really flake here. I can lay this on the table off the form block and straighten that out probably better than just beating on it here, because I'd have to bevel the form block. These are cut pretty much at a 90-degree angle. I'd have to bevel this on a sander or whatever so that this flange can lay down more, but it's really, to me, just as quick and easy to get this thing pretty well roughed out, and then you take it off, and then you can bend these flanges with a hand seamer and touch them up with a hammer on the table. Whatever. Everybody has their own preference of how to do it. All I care is that it ends up being what I want in the end. So I got her clamped up, and I marked my form blocks so I knew which way to bend this. You don't want to bend it the wrong way. You got to throw the part away and start over. This is 32 thousandths thick. On aircraft aluminum, we go by thousandths of an inch thickness. A lot of other sheet metal, like, I don't know, heating and cooling, whatever, they are metal fabrication with black steel or whatever. They use gauge, but on aircraft we go by thousandths of an inch. So here's the sheet of aluminum that I'm cutting these parts out of, and you can see it says Alclad 2024 T3, and up here it's made by Kaiser. Up here it says 0.032 inch, so this is 32 thousandths of an inch. It has a plastic film on it to protect it from getting scratched. And on the first piece I made here, I left that film on until I was done forming it. I took the film off of these that I'm doing now. It's only a few thousandths thick, but that will actually make a difference going around in form blocks. So I'm going to do the rest of these with this blue plastic peeled off. Alclad means when they make this material, the material is 2024. The 2 means copper is the main alloying element. The T3 is the heat treat designation. If I made these out of annealed 2024, this would be -0. But it's soft, you could bend it with your hand real easy. And you have to heat treat it before you put the part on the airplane if you form it out of soft. And then it would be T4 with that heat treatment. T42 or something. T4 is the main T designator. And I have repaired a lot of bent parts on airplanes, especially the P-38 Lightning I restored. And it was my idea to take bent pieces and have them annealed and straighten them out and reuse them, because once we had them annealed, they were soft and we could bend them back into shape like they needed to be, and then send them back to the heat treater and have them reheat treated. And so we reused a whole lot of the original airframe by doing that. And this Alclad means the 2024 material has a thin layer of pure aluminum pressed onto both sides of it when they manufacture it. And that helps prevent the alloy core from corroding, because copper and aluminum are dissimilar metal and they're going to try to corrode each other. The copper is put in there to give it more malleability, and it has a few other elements thrown in there. But you have to heat treat it and quench it in cold water to give it its temper. Now, when it comes off the rolls at the factory, it's T3. If you put it in the oven, heat treat it, and quench it in cold water, then it's T4. And T4 is actually a little harder than T3. Alclad can be reheat treated, depending on the manufacturer. 3 times is usually about as many times as they want to reheat treat it, because the pure aluminum, the core will diffuse into the pure aluminum, which weakens the core, and you won't have as good a corrosion protection. The T-28 had Alclad parts, whether it was 2024 or 7075, they were Alclad sheet metal parts. And I got a structural repair manual for an F6F, a Grumman F6F Hellcat World War II fighter. That airplane did not have Alclad. It had just 2024. And back then they called it 24ST, but it's the same thing. but it had to be primed and painted because it didn't have the corrosion resistance. And that manual tells you if you're going to use Alclad to repair that airplane, you have to go to the next thicker gauge, because the Alclad for the same thickness as the pure 2024 is not as strong because of the pure aluminum on both sides of the part. So if you had 32 thousandths to begin with, you would have to go up to 40 thousandths. They want you to go to the next thicker gauge. Some aircraft repair manuals say it's okay to use Alclad in the same thickness, so you have to pay attention to what the manufacturer tells you to do when you're repairing your aircraft. Okay, I've got the outside flange nice and tight down on the form block right here on the radius, and you see all this extra material just past the radius. That has to, we got to shrink that somehow now. So I'm going to use the fluting pliers on there. Now I can trim my ends off. Always leave a little extra here when you bend these flanges. If I'd have trimmed this thing straight off with the form block, this flange would have not covered. It would have been too short. This one I think would have been okay. I can never remember which ones do what here, so I just leave some extra and then trim them off. But I know if you don't make these cuts, a lot of times your metal goes up this way and then it's too short, so you can always trim it off, right? All right, so here's the parts I made so far. Showed you this one in the last video, and then there's the original piece. Just did this one. This is the piece that came off the airplane. Not quite the right shape. And then this piece is still on the plane. So I got one more piece that looks kind of like this to make, and then etch them, iodine them, and prime them with zinc chromate and get them riveted on. Catch you later. Thanks.